Okay, welcome back again. Working on the Arcology Roguelike. Last time we ended up with a version of what our actual level generator would look like, and we are starting to generate levels that look like this. We are building it based on a template idea, where each one of these sections or rooms are templates, and then we created a little bit of a algorithm, a little bit of a grammar, a little bit of a pattern to fit them all together. So if we're just going to scene view, you will see we've got our one room over here, which is a staircase, because that's only the one up area from the staircase. Then we've got a room next to that, a hallway, some junctions, a whole bunch of other places. And we've got something which looks okay, but isn't really a playable level yet. It's close. It's something that we could work with if our players had the ability to destroy walls and things like that, which I think would be quite cool for them eventually to have. Then that's definitely something that would make this level a little bit more easily playable, but there's still big issues. You can't get to this area over here on the right hand side. You can't actually get from your starting point into the main area, middle area. A lot of stuff that we need to fix. We've got the basis of what we want to do, but we want to actually just build fix it up, clean it up, and get it working. We need to think about this in terms of the actual design of the game, and also in terms of the procedural generation algorithm. Are we going to fix the algorithm, or are we going to fix the design? And I'll talk a little bit more about what I mean by that later on. But there's some things in which our algorithm might not actually generate perfect looking levels, but that might actually work in the context of the game that we're trying to design. So we are still busy with this whole procedural generation algorithm, and this is a complicated thing to do. And as I said in the beginning, this is where I want to start, which is why we're spending so much time on this. But I want to delve into the template approach, but I'm going to do it as part of the actual Trello card over here, just to kind of define what we've done. We've defined some templates. We can pick a template based on our grammar. And defining templates means reading from a file. And what we can do is we can place a room or a room template in sequence. So that's what we can do so far, and that's not too bad. This gives us a decent-ish design and a decent-ish look to our actual levels, but we want levels that are a little bit better. The one thing that we want to still be able to do, obviously, is we want to be able to fill our levels with rooms. At the moment, we're only not filling the entire space. We want to rotate some of our templates. As I said last time, it's all pretty much horizontal at the moment. And what we want to do is we also want to just fix any connections. So, and by connections, I don't mean areas or templates that are connectors, but fix the connections between rooms, the doorways, the way to get from one template to another. Which might be a little bit more complicated than just putting them next to each other, but at least that's something that we probably should do. And the main reason we want to do this is so that our player can travel from one area of the level right to the other area without ever getting stuck, unless there's a game design purpose for it, like a locked room or something like that. But in general, they mustn't get stuck because of our algorithm. Our procedurally generated algorithm shouldn't leave out or create any areas the player can't get to. So what we want to do is we also want to think a little bit about this, not just from a procedural point of view, but also from a design point of view. So this card is very much about our procedural generation algorithm, but I want to talk a little bit about environment design over here, and I'm going to add it under art. And so even though this is an actual card which eventually will have more art-based characteristics to it, this is more defining what our level is going to look like, because depending on what we do over here depends on what our algorithm actually needs to generate, because our algorithm can generate some rooms, some templates, put them all together, but it can't really yet make something that looks like a proper game at this point. We've got the tools, we've got the bits and pieces, but to make it into a proper level, it makes sense in the context of our game, we need to think carefully about, well, what does a level really look like? So there's a couple of ideas that we can play around with over here, but an interesting idea artistically aesthetic would be that our levels are actually these separated stories within a massive building, so that you can't just hop from one level or one story to the next, that if you actually fall off this story or fall through a hole in the floor, you'll actually fall to your death. So the levels are, for lack of a better term, let's say horizontally separated. Levels are or can be partially open. By that I mean gaps in the wall, gaps in the floor, and that adds some interesting possible gameplay elements, which links to our mechanics, where you might have an explosive attack which can push a character, whether a player character or a non-player character, push them back a couple of tiles, a couple of squares, and push them through a hole in the wall, through a gap in the floor, something like that. And we also want this kind of feeling of that our levels are maybe unfinished. We want to really play on this dystopian idea. So our levels have scaffolding underneath. And this will be a visual aid just to let the player know that levels aren't stacked tightly on top of each other. They're actually, there's gaps between levels, gaps between stories, which gives us some gameplay mechanics, but then also very nice, gives us a little bit of aesthetic and a little bit of a feel to our structure as well. So our building, this massive arcology, is really ramshackle, broken down. There are bits of it missing, but it's still standing somehow. But it's a very dangerous place. The environment itself is quite dangerous. Okay, just lost all of that because I used my VI shortcuts instead of saving properly. We want some scaffolding. Levels have gaps in walls and floors. Environment is dangerous. Okay, so this is just a bit of a artistic design, so that when we start building our actual level, and when we start finishing off our algorithm, and when we get to this part of our algorithm where we want to start filling in our rooms with levels and fixing the connections between our rooms, we can actually keep in mind the fact that it doesn't need to be perfect. There can be gaps, there can be holes, and that's what our cellular automata is also going to do. We are still going to be getting to the Polar noise generator, which is really just going to be a way of generating the richness or the value or the difficulty level of the different templates. But before we get to filling our entire level with rooms, let's just play around with this idea of the environment design and the scaffolding. Let's just see if we can do something cool with that. And this is just kind of a placeholder. The eventual design will hopefully look a little bit better, but what we want really is, what I'm just going to do is create a cylinder. I'm going to make it quite tall, and I'm going to make it not as big as the other prefabs that we have. Our other prefabs are 1 by 1 in terms of our unity dimensions. This will be 0.5 by 0.5, and we just want a nice material for this. I'm going to call it rebar because we want, and I'm not going to create an actual proper rebar material because we could probably get a material like that quite easily online, but we just want to create this dark gray material if we can. Okay, let's just see if we can. So we've got this black cylinder. Let's just make the mesh, the material a little bit smoother so it's a little bit more visible. We run this. The idea is that, this is just an example, of course, underneath all of our buildings, templates at random positions, we are going to place these scaffolding rebar pieces to show the idea that there is a level somewhere behind us, but it's not directly below us. So that's the idea that we want to do with that. So cylinder is just going to become scaffold, and we're going to drag that into our prefabs folder. We've got a nice scaffold over here, and then what we're going to do is in our map generator script, remember this is a script that actually displays a room, we're going to add the scaffolding. Scaffolding has got no actual gameplay impact. It's just a visual effect, if I can call something as basic as a cylinder, something as fancy as a visual effect. But the real idea is just that this is just to give this idea that we are all actually, each level is somewhere in the sky, precariously perched above another level. So we're going to add all of this code into our level generator. It's going to be part of our display method. So at the moment, our display method just instantiates new prefabs. What we want to add is a random scaffold generator. Let's just add a public value over here. Which I'm going to call scaffold chance. Basically, that's going to be a value between 0 and 1, and that's the chance that any specific tile has a scaffold beneath it. So we just need to have an if statement, random dot range 0 between 0 and 1. If that is smaller than our scaffold chance, then we generate a new scaffold. I'm going to define a specific game object for the scaffold, because this is not really linked to my tiles or anything like that. This is more of an effect at the moment, and this is just to play around with this idea. This is a design and art idea that I have. This, what we're building here, is still the prototype of a procedural generator, but I think this will give us an idea of whether this concept of being able to fall through the level actually makes sense visually as well, if the player will understand what we're talking about. So we instantiate a new scaffold. We instantiate it at the exact position as the other tile that we've generated, but obviously 3 units lower on the y-axis, and we just need to fix up the values within our inspector here. We give a 0.25 scaffold chance, which is probably quite high, but that's fine. And then we add a scaffold game object to the scaffold property or field over here, and then we run and test it. Ooh, that actually doesn't look too bad. 0.25 is a little bit too high, but we're getting a bit of a feeling that there's some kind of scaffold this is floating in the air. This is based on something. Okay, 0.25 is way too high. Let's make a 0.1. 1 in 10 chance that any single area will have some scaffolding. It's still quite high, but our level is starting to look maybe a little bit like something that is you're randomly floating in the air. Let's make that 0.05. That's almost looking... This idea is not finalized, it's not perfect, but that's actually not looking too bad. We can add some nice rebar texture to it, make the scaffolds different lengths. We can actually have something quite nice working over here. But I'm not going to mess too much about with that idea. This is just a small idea I had to make our level really feel like it's floating in the air. I don't want to spend too much time on that if I can. So that's the level design, the scaffolding, this idea that levels have gaps in the walls and floors, and it looks like it could actually work out quite nicely, which means that our filling our level with room doesn't need to fill it completely. We can have open sections, and then we can use one of our other techniques to actually break open sections. The idea being that you're fighting up 400 stories in the air, the wind is whistling past where you're fighting, it's open, adds this extra sense of danger, extra sense of decay, really lends to the dystopian aesthetic as well. Lots of interesting stuff we can do with that, but that's what we want to do. So let's talk about this idea of filling our level with rooms. So at the moment, our algorithm for doing that is part of the procedural generator class. And what we do is we generate rooms until we've reached a certain number of rooms. You say, okay, well, we've got a whatever value that might be. Keep generating rooms until you do that. It's going to place rooms on top of each other and over each other, which is actually not the worst idea. You could very easily imagine that as this building was being built, pieces were being rearranged and built over each other. But at the moment, this is really much based on this idea of the initial structure. 30 rooms, 40 rooms, whatever it might be. But we want it to be really a percentage of the height. At some point, we want to, of the size, the width and the height of our level. We want to generate a number of rooms based on that, maybe for 80% or 75% or whatever it might be of our total area that we have for our level. This will also be determined and based on how decayed this level is. The less decayed it is, the more tiles should be filled. Ideally, the lower down you are, from a structural point of view, you would have less open spaces. The higher you get, you would have more open spaces, which also then starts adding some interesting gameplay mechanics as well. Do we add mechanics to allow a player to jump across areas if they need to get to an area that's maybe isolated from the rest of the map? So lots of interesting things we can do with that. So I'm going to change this number over here to a float, which over here will become not number of rooms, but coverage. So basically this is a percentage value to saying how much of our map have we covered. So the for loop I'm going to change to a while. So while our coverage that we want is less than the current coverage, which is a variable which we'll still define, well, keep trying to generate new rooms, which works fine for us. We just need to set current coverage define it over here. And then we need to calculate it. So basically every time we place a new tile, this is needs to add to the current coverage that we have. So I'm just going to update our debug message. Our type generation is fine over here, but what we want to just say let's just make this nice and neat. Current percentage is obviously a value out of between 1 and 0, so if we want to get a nice visible percentage that we can display, we just times it by 100. Okay, we don't add we do add, sorry, actually we do actually add the values individually. So I'm going to add some coverage generation code over here. I'm just going to generate a max coverage. We only need to do this calculation once. It's equal to width times height, whatever that might be. Our current coverage is then, well, we need to generate this before we actually update that specific tile, because we need to know what it is. We say if the level at X and Z, if that position is equal to tile type.empty. Have an int here as well for that. Okay, num tiles covered and max coverage. I'm just going to change black to floats, else we are going to get problems with integer division where it's going to round it for us. Okay, let's just think about our logic. We start out, our current coverage is 0. This current coverage is actually just a value that we want out of, it's a shorthand for a percentage, value between 0 and 1. The number of tiles covered, that's currently how many tiles we've got covered. Our max coverage is the maximum number of tiles we possibly could have, which obviously the width times the height. What we do is we keep randomly placing tiles and randomly placing rooms while our coverage that we want, which we pass through as a parameter, is less than the current coverage. The current coverage we work out whenever we generate a new tile. If that tile type was empty, in other words, we are actually increasing the coverage because we will have some tiles that will overlap, so we don't want to include that in our coverage. Then we increment the number of tiles covered and we recalculate our current coverage by basically just doing a percentage over here. Neaten that up a bit. Our debug.log should give us a percentage covered over here. Okay, let's go back to Unity. Let's just save this. Should 0.8. Let's make it 0.5 because the coverage, once we start playing around with these kind of random values, we have to hope that we get everything. So it needs to randomly generate enough actual coverage, in other words, fill enough empty spaces fast enough. So let's start with 0.5 and then we'll build up from there. Okay. There's something wrong with my logic. Yeah. This is the wrong way around. Well, my current coverage is less than the coverage that I desire. Then we keep generating new values. Let's try that again. Okay, coverage. Should be stopping at some point. Got some additional debugs. This is the biggest problem with adding too many debugs. We know that our start and start positions are fine. What we're really just interested in is the percentage covered, which we're not getting enough of because our debug.log is debugging everything else out. Okay, it's just taking a while to reach 50% coverage, which is actually quite interesting. I didn't think 50% would be that difficult for it to reach. Okay, let's stop that. Let's make our coverage 40%. Seems rather low, but let's test that. 35, 38, 39, 40%. Okay. Generate that. Let's just zoom that out a bit. We get what is definitely an interesting looking level. Check our stats. Our FPS is still fine. I'm worried that if I generate too many blocks that we will get some lag, but our FPS seems fine. We've got one tiny little problem over here, which is fine for now. It generates a starting point first, and then, well, you can play through the level decently enough. This actually generates something which would be a almost playable level. We've got weird little gaps and things which don't really work with the kind of aesthetic that we are going for. Remember, the aesthetic that we want is the idea of this is all ramshackle, there's bits and pieces missing, holes within our actual level. So let's change our initial structure here. This value I am now going to parameterize because we're starting to use this quite a lot. So we can actually set this in our level settings as well. Let's make it 0.25. And hopefully what we'll get is something that's a little bit more spread out. We've got some gaps, but that's not the end of the world. One thing we want to do is really fix the rotation. I'm getting a bit annoyed with these lines and lines and lines of holes. If we have different types of venues as well, that would work. And this is fine. I mean, this is a dystopian future. You could have a hallway that leads to the beginning of another hallway over here. This is fine. But two things over here. We've got nice spread, but what we really want to do, let's see if we actually add it to our, let's update that. We want to fill our level with rooms, which we can do pretty well, at least now, but we want to prevent too much overlap. Some overlap is fine, but we don't want this kind of stacked effect where we can have three hallways on top of each other. Let's see if we generate something like that. This is obviously taking a little bit longer to generate because there's more to do, so we will need a nice loading screen. But if we look at this area, for example, we've got hallway, 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 all kind of together, which is a bit excessive. So we want to get a more realistic view, a more realistic level, and we want to make it so that it feels a little bit more like an actual building would be. So the one thing that we've done is we've got this our little algorithm over here. It's basically saying if it's a connector, switch back to area. If it's an area, switch back to connector. And this is not really how it works. Usually you've got a bunch of rooms surrounding some kind of connection area around the hallway or a junction or things like that. Our junction, indeed, in its design has got 4 open spaces next to it. So what I'm going to do is I'm going to just add a little bit of a counter here, which is going to say that the moment we generate a new area room, we're going to randomly generate a counter. And what this will do is to say, okay, we need to keep generating. There goes my mic. We don't want that. We need to keep generating rooms until this counter has count down, area rooms, and then we can go back to connectors or whatever other type of room that we might want to have. And this links back nicely to our procedural generation, our level grammar, where we've got the idea that we've got multiple options of rooms. It should be for every connector that we create, there should be at least 3 other rooms, 3 other options over there. So what we're going to do over here is we are going to define a current room type number is equal to 0. Just think about this. Basically, we're going to generate a room if is equal to some value. Let's make it 4 over here. We'll fix this, don't worry. My indentation has gone a bit wonky, but that's fine. If we've counted up to 4, well, then we change our connector type. If not, that's going to frustrate me. Let's just fix this. Okay, the other ones are fixed, that's fine. If it's not, well, we're going to say we want to increment our current room type number, and we want to set last room again to area. And this 4 over here, we're hard coding for now, but this basically says that there will always be 4 areas to per connector. Add some randomness to this, but at the moment this should be fine. Okay, let's just go through our logic. We've got a room type number starts at 0. we keep counting up. Once you reach that number 4, which means we've created 4 areas in a row, then we can create a connector again. So what this basically means is our grammar is now actually that we need to have 4 connectors, 4 areas, per connectors. No real way to define this in our grammar, as a grammar is not usually that specific in terms of the numbers, but we've hard-coded that in the code over here. So let's give this a try. And it's gone and done the exact opposite of what I want. We seem to have a whole bunch more connectors and a lot fewer rooms. Interesting. Yes. Okay. We put this in the. We checked if the large room equals area, but that means we've just placed an area. So what that actually means is we want to put this in our connector. Class. Hang on. Let's just go back. The last room is a connector. Create one of the area templates. Then say that the last room was area. If the last room is area, okay. If and only if we get to our final value do we create a new connector for the number of room types. Otherwise, please keep creating areas first. Okay, this little grammar of ours is getting a little bit complicated, so we probably need to start thinking about ways we can abstract this out at some point. But for now, it should be working. That looks a little bit better. We've got some connection areas, but we've mostly got like the junctions. We don't have a lot of hallways that I can see, but we've got a lot more rooms that are staggered together. So let's just, there's a little bit of testing, and we're just playing around with this, but let's just make that 3 instead. We still have the fact that things, the templates are overlapping, so that means we're probably losing some of our connectors with the overlapping process. 2 junctions next to each other, which is fine. There's a nice door, hallway over there, looks to another hallway over there, a whole bunch of rooms together. This looks like an almost interesting playable level. The one thing that we have to be careful of is we've been lucky in the sense that we always kind of start, our starting entrance is always on its own. This is not always going to be true, and as you guys can see, this is actually the only playable area that we have, even though we've got all this other area. With our current mechanics, because we haven't defined anything like a jump mechanic or a wall destruction or ladder mechanic or whatever, the player cannot actually get to the rest of the map. So what we now need to start doing is thinking about overlapping. We want to make sure that the overlapping doesn't happen so that we can actually put everything together properly. Okay. Let's just pop back to our Trello page over here. We're filling our levels with rooms. We've actually also managed ratio of room types. This might This is something that still needs fixing, but it should be fine. The next big thing we want to look at is this preventing too much overlap. So if we go back to our code over here, at the moment what we're doing is we're picking a random position, start X, start Z, so randomly generated, and then every time we check, well, should we be generating something over here? We check the new start position. All that we're checking over here is it within the actual parameters of our map. We're not checking if it is actually, that's the word I'm looking for, occupied or not. So there's a couple of ways in which we can do this. We can go and check every possible space, but let me just think about that. It will work. Let's give that a try. We can steal this for loop because this should do the same thing that we want to do. No, we don't. That's a nice over there. Okay. Logic for checking if the possible next room is empty seems fine. If you find a boolean saying that the next room empty is true, that means all the possible squares, all the possible tiles that we could possibly have a look at are empty. We then go and check through all of them, which means we need to say, well, not the room we've just generated, but where we are going to be generating a room. So this is where it gets tough. Gonna fix this, don't worry. Silent moments where I'm thinking quite hard. We're saying, well, you've just generated a room. It started at X and Y, but it had a width and a height that we defined. So we want to start from that width and height, the new position. If you think we're generating from the bottom left corner up to the top right corner, we're going to start from the top right corner and see if any of those positions further on from that, any of those from there up until the maximum size our template could be, are they all empty? That's ideally what we want. One problem we have with this is that this either one of these values could very easily be outside of our maximum map size. So what we're going to say is, if you are inside our maximum map size, what we're going to be doing is we want to find a new random starting position. Before we can do that, we want to we need to keep trying to find new spots until we can actually get a new start X and a new start Y. That is inside our actual inside our level, as well as being in an empty spot. is where we just need to carefully think about how we're going to do this, because code at the moment just checks for if we're inside the level. It doesn't check if we are where we're going to be creating it is empty or not. It just assumes if we are inside the level, we pick another position at random, and we just create a new position there, which is fine if we're trying to avoid the out of bounds exceptions which we had previously, but that's not fine if we want to make sure that we can actually generate a new room or not. Okay, let's check our logic. We first of all decide whether we want to come on. We decide whether what the new type of room is that we want to create. We define the new room. We then go and get it from the template based on our little grammar. Then we check the place where we want to create this new room. Is it empty or not? At this point, we haven't created the room yet. So we can simplify this a lot, which is very nice because it's just feeling a little bit like a code smelled to me. Trying to do something a little bit too complicated. If the next room is empty, well, then we go through everything else. If not, then we go through the process of moving to a new position. This should work. He says, hopefully. Coverage is working. We might have trouble reaching our 25% coverage because nothing can overlap. The fact that our coverage is taking so long means that our actual overlapping is actually being tested and checked. A little bit more complicated and taking a little bit longer, so we might need to work on our desired coverage over here. Problem is we're trying to fit in rooms. There might just not be enough space. Let's just cheat and see what it looks like for now. We've got a whole bunch of stuff that's kind of connected. So we've got no overlapping. Should have better chance of getting up to that 0.3, 0.2 or the 20% coverage that we're looking for. It's trying. Okay. We've got a level. entrance is way off to the side, and our we're not getting full coverage that we would like. We're not getting connections between the rooms that we would like. The big issue that I'm worried about is if we keep the algorithm like it was, we get overlap, which is not the end of the world. We get everything joined, because that's how we're saying it should be joined. But we've got a possibility that our starting point could be randomly replaced. But as nice as I think that empty checker code was that I wrote, this kind of view actually gives us a little bit of a nicer playable level. Except for some issues with our walls, we can basically, all our rooms are connected. There are some gaps, but those gaps are fine. There are no major gaps. There's some isolated islands. We could probably write a little bit of a piece of algorithm or code to get to them. A whole bunch of junctions next to each other are overlapping. It's a bit weird. There's some weird stuff happening. But this gives us a random enough level, really, that we can work with, and that we can actually make something of. This is almost a playable level. There was a door over there, door over there. We could probably get through this. So over here we have to think a little bit about game design issues or level design issues. We can probably wonder about that, but we could probably fix this through some level design. So let's update our level design somewhat. What I'm going to do is I'm going to add another connector template, which I'm going to call platform. Platform is going to be very, very basic. We just need to define that within our room templates. Let's take staircase, platform, platform is really just going to be, no, I'm just going to delete everything because that's going to be easier. A 3x3 area of floor. One is floor. Yes, that's correct. We should also probably abstract this out at some point, that it goes and finds all the rooms within the room templates class. The rooms.txt also keeps track of the actual room type that it is.
but we will do that later on. So platform should give us a nice little empty space to work with. I'm going to make platform an area so that we've got these small little empty spaces that we can work with. Let's see what that looks like. So those little areas like that, those are all platforms. And that's actually kind of giving me the effect that I really want. I want the idea that you've got open spaces where you're on the edge, you're on the ledge over here, it's quite dangerous. But you've still got something that's playable and that you can actually work through. So what we probably need to do now, this kind of level, is definitely playable. What we just need to make sure is that we can actually get to every tile or most of the tiles. And that we can actually enter this level. We need an entrance. So what has happened in this level is what I was worried about. One of our generation loops has overwritten the entrance. So if we just try and run through that again, we've got a staircase all on its own over here, which is really, really boring. I don't know why that's over there. There we've got a staircase, which we can see if we actually search for. What we've done over there. So what we have is we've got our grammar which defines that our whole level should start around a staircase. What we want to do is we want our start X and Z to be closer to the middle of the map. So I'm just going to we'll fix this up still, but we're going to say within the center of the map somewhere we want our entrance. This is something we can obviously change later on. I hope this is going to work. Yeah, Arcade is going to work. Right. So our initial entrance will always be somewhere close to the middle, or closer to the middle of the room. So obviously, this is the problem that that middle of the room could easily be overwritten. So let's see if I start searching for there. Case, nothing pops up. So what we're just going to do is we are going to save our start X on Z positions. And then once we've gone through this as many times as we possibly wanted to, we're just gonna redo this bit. Basically what we're doing at this point is we are replacing our entrance in the middle of our map. Which is fine, but kind of defeats the purpose of everything we've been doing up until now. At least this way we know that we will always have a entrance that our level can start with. Yeah, I don't like this. This is not right. When your code kind of screams at you and says, what you're doing is wrong. We've got the code for this, but just adding that over there. We can use our if next room is empty. some code to check a room for a specific value. We're just gonna switch these around. It's our logic, our variables make sense. So at any point we are trying to generate an entrance or a room on top of an entrance, we should skip over that generation and that position and generate a new room. Let's try that. For some reason it's generating 4 copies of everything, which I have to admit is worrying me. But we are getting staircases. Close to the center of the room level. Look at that. So close to an almost playable level. Previously said we don't want double walls, but if we don't know whether if we've got a room with a door in it and then we overwrite it with another room that's just got a wall, we're going to lose our doors, which is going to be causing some problems. And later on we can add some code that'll actually check everything and make sure that our rooms all have doors or passageways leading off each other. So even though this is a double door system, that's fine. We've got a platform. This room overlapped with another one, which it shouldn't have done. Not perfect yet, but getting quite a lot more playable. Compact room over here. We got a lot of things that are actually working. It might not look that way, but what we really need to do now is what we've also done over here is we've guaranteed having an entrance. We want to rotate some of our rooms when we place them. We want to, I say fix connections between our rooms, but we need to actually check connections between our rooms. And we also want this decaying serial automator effect to be able to run through our level. So if we generate a level that looks like whatever a level might look like, let's have generate one just for as an example. If we generate a room like this and we've got an area like that over there, you might not be able to see it that clearly, but this area over here, we've got 2 walls next to each other we can't get through. If our cellular automator actually then goes and deletes those areas or replaces them with a floor area, then we can actually get a very nice kind of, let's say there's some kind of ragged gap effect. then we actually get something that could actually maybe be, you see this little almost tear that we have here, makes this a possible space that we can go from one room to another room. So our cellular automator kind of approach, where we're going to use to add some organic feel to our whole level, might end up opening up a lot of spaces for us that we might not necessarily have had. The idea is that you can have very few rooms that are just rooms, solid rooms, with no ins or outs. So what we want to do is we want to do a whole bunch of stuff and then run a couple of checks on our entire actual level to make sure that whatever we're doing makes for a playable level. We want to think a way of doing this without having to check that every single square is reachable. There are some algorithms to do that, and we might need to end up doing that, but that is not what we are too worried about at the moment. Next main thing we want to do now is, after we've done all of these different things, is we want to rotate some of our templates, so that things like our hallways and things like that, which we don't seem to be generating too many of, which is a bit worrying. Something that looked like it was a hallway. Let's just those hallways were a nice effect, and I think they'll have a nice gameplay effect as well if you fight your way down this long hallway. We seem to be losing them in this generation process. Looks like we're getting some hallways, but looks like they're getting overwritten quite a lot, which we can fix. We can fix that. This is a playable level. It's looking more and more like a playable level. Start out there. Move through this double door, move through this door. There's an option to go through there into that closed room. We can go through there. If we allow diagonal travel, we can go through there. If we allow jumping, we can jump over there. A whole new world, like the wonderful Aladdin song, awaits our play if they can go through there. So we definitely have options that we can play with. So we've played around a little bit with the ratio of connectors to areas, and we can probably still play around a little bit more, but this ratio that we have at the moment I think looks good to me. What I really want to get to, and I keep putting it off, is rotate some of our templates. It's probably the last thing we're going to try and get done tonight. So how do we rotate a template? Well, essentially, if we swap our X and our Z options from our 2D array and put our X in our Z and our Z in our X, we should get the swapping effect that we want. It should be technically that easy. Let's try that out. We're gonna have to just fix one or two things, because it's going to be difficult for us to see if this really works, though we should be able to see it from our one room which has got the crates in it. So we do good old random.range 0f1f bigger than 0.5f. Well, then we keep the rotation as it was. otherwise, should be as easy as swapping these values around. Let's give it a try. Yeah, no. Not that easy, because our heights and our widths have changed. We're probably gonna have need a whole new if statement for this, for loop for this, sorry. Little actions you see me doing with my fingers, just thinking out loud or in the air. This is the kind of thing I've done by accident before. Let's see if I can actually do it on purpose. Oh yes, look at that. We've got some horizontal and some vertical rooms over there. Horizontal, vertical. Not a major difference, but we've got some rotations actually working out over here. I just want to go back and check something in my code. It really feels like I'm not generating any hallways. And that's not too critical for us. Okay, we are really getting somewhere. It's not perfect yet. And what we'll need to do now is to add an algorithm which will make sure that our level is actually completely playable. Even if there are doors that you need to pass and doors that you might need to hack or get through in some other way, every area, every floor tile on our level needs to be regional, and we're going to need to use quite a complicated algorithm to get that done. And we're adding more and more complexity to our code, which is not the end of the world, but it does mean that we are ending up with some possible issues in terms of the generation speed. Our FPS is still looking pretty decent, if you're considering that I'm streaming as well. There's a lot of stuff that we can still fix in terms of the FPS. There seems to be quite a lot of, or a couple of overlapping prefabs that are being created. Some of our prefabs have got sections or sides of the meshes that we're not seeing, so we can always think of some way in which we can weld those together if need be. But at the moment we want all our prefabs to be individual prefabs so we can create and destroy them dynamically during gameplay as well. That might be something that we want to do. We've got something here that's looking similar to what we had last week, but a lot more spread out and a little bit more structured. There's a little bit more focus to what we're doing, and we've got our nice little scaffolding poles over here. What I just want to do as the last thing before we finish is just unpack this prefab. I really like the idea of our scaffolds being even a little bit longer. Get nice thin scaffolding prefabs, and then in our display code we change that to height of 4, so our scaffold generates better. We need to re-add the scaffold then just to that class over there. Let's just make the desired coverage even a little bit lower. We got a little bit more of a spread out map. And that is looking like something that is interesting, it's playable. Still some stuff we need to fix, a lot of stuff we need to fix, but this is looking a lot more like an actual game level that could be playable, that makes sense. What we might want to do is later on add some really long scaffolding pieces in the empty spot so that we've got the idea that there's another level above us as well. That would also be quite interesting and quite cool. But I would not want to do too much of that, because that might interfere with our actual line of sight or viewing of our actual gameplay. Because if you've got this very tall piece of scaffolding that comes up to here, for example, we might not exactly be able to see what's going on. And even if we add rotation of the camera and stuff like that, which we will, that means that our eventual player will have to move around sometimes to be able to see what's going on, which is not ideal. And we don't want to mess around too much with raycasting and clipping and all kinds of weird things like that. Okay, so like we did last time, let's just go back to our game view, maximize our gameplay, remove the stats, we're not interested in that, get the snipping tool so that we can steal a nice little thumbnail for the next video. Well, for this video. Okay, and with this image of a level which is looking interesting but highly unplayable because our entrance is floating in the air, I'm going to call it a night. Next time we get together, which will hopefully be tomorrow, we'll look at actually making our levels properly playable. We're close. Through random generations we can get to levels that are looking good, that are not looking too bad, but what we really want is actually just to get levels that are properly playable, and that's the next big thing that we want to do. But our levels for our game are looking like real levels, and once we've got these levels in place, doing the actual gameplay and combat and that is going to be a lot easier to test. It's not going to be easy to do or to balance, but having a level within which we can actually test it and play it does make our lives a lot easier to do that. And as I said, this is one of the more difficult things, but possibly one of the more interesting aspects of the game as well. I hope you guys enjoyed that, and then next time we'll look at really trying to get this level generator finished off and working properly and actually looking quite nice. Thanks so much for watching.